Google's breakthrough LLM architecture, separating memory functions for enhanced efficiency and cost reduction. Written by Liquid Ocelot. Imagine a vast library filled with countless books, each containing a piece of information. Now imagine a librarian who can instantly access any book in the library and use its knowledge to answer your questions. This is the power of large language models, LLMs, which have revolutionized how we interact with computers. However, even the most advanced LLMs have a limited memory. They can only access a certain amount of information at a time, which can be a major bottleneck when dealing with long texts or complete texts. This is like asking the librarian to answer your questions after reading only a few pages of each book. Researchers at Google have recently developed a new neural network architecture called Titans that aims to solve this problem. Titans enhances the memory of LLMs for allowing them to access and process much larger amounts of information without sacrificing efficiency. It's like giving the librarian a superpower to instantly absorb the knowledge from every book in the library. The secret behind Titans lies in its unique combination of short-term and long-term memory. Traditional LLMs rely on a mechanism called attention to focus on the most relevant parts of the text. This is like the librarian quickly scanning a book to find the specific information they need. However, attention has its limits. As the text gets longer, the librarian has to scan more pages, which can be time consuming and inefficient. Titans overcome this limitation by introducing a neural long-term memory module. This module acts like a separate storage unit where the librarian can store important information for later use. It's like taking notes or bookmarking important pages in a book. When the librarian encounters a similar topic later on, they can quickly access their notes and retrieve the relevant information without having to scan the entire book again. But how does Titans decide what information is worth storing in its long-term memory? It uses a concept called surprise. The more unexpected or novel a piece of information is, the more likely it is to be stored. It's like the librarian being more likely to remember a surprising plot twist or an unusual character in a book. This ensures that Titans only stores the most valuable and relevant information, making efficient use of its memory capacity. Furthermore, Titans has an adaptive forgetting mechanism that allows it to discard outdated or irrelevant information. This is like the librarian periodically cleaning up their notes and removing anything that is no longer useful. This ensures that the long-term memory remains organized and efficient. The researchers have tested Titans on a variety of tasks, including language modeling and long sequence language tasks. The results are impressive. Titans outperforms traditional LLMs and other memory-enhanced models on many benchmarks, demonstrating its ability to handle long and complex texts. The development of Titans is a significant step forward in the field of natural language processing. It has the potential to unlock new possibilities for LLMs, enabling them to tackle more challenging tasks and interact with humans in more natural and engaging ways. Imagine a future where you can have a conversation with an AI assistant that remembers your past interactions and uses that knowledge to provide more personalized and relevant responses. This is the promise of Titans. The researchers believe that Titans is just the beginning. They plan to continue exploring new ways to enhance the memory and reasoning capabilities of LLMs, paving the way for even more intelligent and human-like AI systems. As this field of AI continues to evolve, we can expect to see even more groundbreaking innovations that will transform how we live, work, and interact with the world around us. The implications of Titan's impressive performance, particularly with long sequences, are significant for enterprise applications. Think of it like upgrading from a small local library to a massive online archive with instant access to a wealth of information. This is what Titans enables for large language models. Google's being Google, being a leader in the development of long context models, is likely to integrate this technology into its own models such as Gemini and Gamma. This means that businesses and developers using these models can be able to leverage the power of Titans to build more sophisticated and capable applications. One of the key benefits of longer context windows is the ability to incorporate new knowledge directly into the model's prompt rather than relying on complex retrieval methods like RAG. Imagine being able to give an LLM detailed briefing on a specific topic or task all within a single prompt. This simplifies the development process and allows for faster iteration and experimentation. The release of PyTorch and JAX code for Titans will further accelerate its adoption in the enterprise world. Developers will be able to experiment with the architecture, fine tune it for specific tasks, and integrate it into their own applications. In essence, Titans represent a significant step towards making LLMs more accessible, versatile, and cost effective for businesses of all sizes. By extending the memory and context window of these models, Titans unlocks new possibilities for innovation and automation, paving the way for a future where AI plays an even greater role in our daily lives.